Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, welcome to the 10th module. In 10th module, we will learn about sequential files. Sequential files are used so that the result of an executable program can be stored permanently in any storage device, not temporarily disappearing when the program is closed or stopped. The goal is that the data that has been stored can be reused. For example, when you create a program without using a sequential files, the input data in the program will be deleted when you close the program. But if you use a sequential files, the data that you input will be stored permanently and you can use it again when you open the program. For the example is login registration program. In this program, you will be asked to create an account first, and then when you have finished register, the account data will be stored permanently in the program, so that if you close the program, you can go directly to the login menu, then you use the data account that you have registered before. The next is file pointer. File pointer is a pointer which is used to handle and keep track on the file being accessed. A new data type called file is used to declare file pointer. This data type is defined in standard studio.h header file. The structure will store the current flow information of the file being used. The general form is like this: file, asterisk, file pointer identifier. For the example is file asterisk fp. File pointer identifier you can change to whatever you want. Okay, the next one, we have stages of file operation. In sequential files, there are 3 stages you have to do. First one is open or active the file, and then processing the file. The last one is close the file. The first one is open or active the file. This is general form of open file. File, fopen. This is asterisk, fopen. File name, you can change this. And mode, you choose mode here. Okay, next. This is modes on sequential file. R, W, and A. R is open file for reading process. W is open file for writing process. And A, open file for appending process. The difference between W and A is W will delete the old file, but A, appending, doesn't delete old file. The file will get updated if we choose appending or A. And then we have R+, W+, and A+. R+, same as R, but also can be used to write. W+, same as W, but also can be used to read. And A+, same as A, but also can be used to read. R+ and W+ look the same, but they are different. The difference between R+ and W+ is R+ should be supported by a file. So if we don't have a file, we can use R+. But W+ can be used even if we don't have a file. And this is the example fopen function. This is fp file, fopen for open, and text.txt. This is file name, and W. This is mode.
The next one is processing file. Before we process the file, we need to know what kind of files or what types of files that we are dealing with, because there is 2 types of file. The first one is text file and the second one is binary file. Text files is used to store data like character and string, while binary file can be used to store complex data like structure. Okay, binary file are also processing the data from like in the form of memory blocks consisting of bytes, such as memory in RAM. Also, there is difference between both of them, which is when using mode argument on the fopen function. In the text files, you use like what I already explained before, which is R, W, and A. or with the plus counterpart. While in binary file, we use an extra character in the mode itself, which is B. So, example, you want to do some reading on binary files. That means you're not gonna use R, but you are using RB, and same goes to W become WB and A become AB, and same goes to the plus counterpart, which is becoming RB plus, WB plus, and AB plus. Or you can write it as R plus B or W plus B and A plus B. After knowing the difference between text file and binary files, now we can go into processing the text files. In text file, there is two different procedures. The first one is writing and reading string data in text file, while the second one is adding string data in text file. Now, there is a common function that will be used in writing to text file, which is fprintf. It's different to our commonly used printf. Why? Because fprintf can be used to write to a file, while our commonly used printf only capable of write to the screen. Now, we can see the example code. There is a declaration for string and then declaration for file called f_text, which means fopen file called contoh.txt on W modes, which is writing. The next one is get string, which is when our typing or our input on screen will be gets into a character named string, and then it's gonna do fprintf to f_text, which is contoh.txt in writing mode, in the form of %s, which is a string. Well, string itself got from a character named string, and then fclose to close the file back. Okay, for example, we can write chicken. Okay, the code is successful. Now into the reading one, you can see the different code we used in here is, while declaring the f_text, the fopen mode is now reading instead of writing, which is R. Now, while f gets or file gets string in the size of string from the contoh.txt or f_text is not equal to null, then printf string from the contoh.txt, and then fclose the file back. Okay, see, while executed, it will write chicken because we already type it into the fwrite. If you want to check the file by yourself, you can open the folder for it. Because we use contoh.txt, then we can open the contoh.txt. Okay, as you can see, it's also have chicken on the data. Okay, close that. Now the next one is gonna be adding a data into text file. While adding the data into text file, it's not that different. The only difference is on the mode that we use. For example, in here we got the same exact code from the writing one, but instead of W in f_text and fopen, we use A for appending instead. Now we can run the code. We type duck. Okay. To check them back, we can use the previous code for the reading one, like this. See, it's now have chicken and duck instead of chicken only. Or we can also check on the file again in contoh.txt. Now we have duck on the second line. Why we use A instead of W? in the appending, because if we use the W, the chicken, the one already in the file, the txt file, will be replaced by duck. So if you look into the first code again, we run the program, and then we type duck, and then we rerun the second program for reading. It's only set duck. Same goes to the file, and it will also set duck. Now, after knowing that how to process in text file, now we go into binary file. The difference in binary file is there is two more procedure, which is open random data from binary files, and the fourth one will be deleting data from binary files.
Writing and reading data in binary files. Now there are two commands that we need to learn, which is fread and fwrite. Fread is going to be command to read a file. Here are the basic form of fread, which is the top one. Fread for restrict ptr, which is pointer, a pointer that points to an area of memory that will be used as a temporary data storage for reading or reading data or files. Next is going to be, there's a size. Now a size is what memory block in bytes to be read or written. Next is going to be nmemb, which is adds a number of memory block, or nmemb is a memory block to be read and be written at one time. Next is going to be a file stream, which is going to be a file pointer that points to the file. Now size t is a special integer that the data types, they can store the size of an object stored in a memory in bytes. Size t like 0. Now this is the basic form of a fread command, and this is going to be the basic form of an fwrite command. Notice the fwrite and the fread. Okay, next let's just jump to the codes, or the program. First, there's the header declaration. You have the int main on the second line, and then we have the file declaration on the third line, which is called f structure, the line. This is the declaration of integers. There are n and I. On line 5 through 8, this is going to be a struct called a list, and inside this list there is a char or character. Well, to be exact, this is to be precise, this is a string called menu. The variable is called menu, and there's a variable double called price. Okay, on the 10th line, this is going to be the program. In the program, this is going to be where the files is being opened, as you can see from the fopen. This is the file name, this is the extension, and this is the modes, which is right now is running on written or writing in binary forms. That's why it's W and B. On line 11, this is going to be the input, or the amount of input that you wanted for the menu. Number 12 is going to get that input. Number 13 is going to be looping around, it's going to keep repeating for how much menu you wanted. And on line 18, there's going to be the fwrite. Fwrite is used for writing something into a file. In this scenario, the file is called pricelist.dat. Now this fwrite will take the struct called list, and the size is going to be the size of the struct of list. The memory block range is going to be 1, and the file that you're going to be adding is from the f structure. The stream is going to be f structure. And of course, after you open a file on line 10, you need to close it before doing anything else. In line 21, you have the fclose function. Now let's just run this and see how it works. Now it will be asking you on how much or input the amount of menu you wanted. So how much menu you wanted? Let's say I wanted the 2 menu. The first one is going to be fried rice. The pricing is going to be 15,000 rupiah also. The second menu is going to be fried chicken. Yes. Chicken. The price is going to be, let's say, 15,000 rupiah. And there you go. And right now you are finished on writing something, or to be exact, writing these 2 menus into the file. So to check whether or not your program succeed, one of the ways is that you can probably just go to the directory on where your program is located, and then find the files that you created. In this scenario, it's called price list, and if you double click it and open it with Notepad, and as you can see, and you can probably see right now that some are readable and some are, I don't know, and this is because it is the nature of binary files. It doesn't just store it in plain text, but it's stored it in a bunch of zeros and a bunch of ones. Some of those zeros and ones are readable by notepads, but some of them are not. Okay, next we are going to be looking at the read program, which is going to be reading this file right here from the console command. So in the first line, we have the header declaration. On the third line, we have the file declaration, and the same on 5th to 8th line is going to be the struct declaration. It is named list, the same as previous, just to avoid confusion. And then on the 10th line is going to be the process on which the file is being opened. Notice the mode is going to be read binary, or RB. Now on the 12th line, you can see this is where the fread is located, but there is actually a condition. There's a while before it. Now fread works that whenever it found something or it can read something, it's going to be outputting a 1. That's why there's a condition that whenever fread is outputting a 1, you're going to be printing whatever it's contained with it. But if fread no longer find anything on the files, let's say it cannot find anything to read, then it's going to be outputting other than 1. Now, of course, after you open the file, make sure you close it. Now let's just run the program and see how it works. And as you can see, it outputs the things that we have written before, or we have written previously in the other program or in the right program. The first menu is going to be fried rice, priced at 15,000 rupiah, and the second menu is going to be fried chicken, priced at 13,000 rupiah, which is exactly what we inputted before. Now the second subpoint is going to be adding data to binary files. Now just like text files, adding data and writing data is actually almost similar. The only difference is that when you're opening the file, make sure you use the correct mode. In this scenario, which is adding data, you're going to use append. Now as you can see, this is the program or the codes that we use to add another menu without overwriting the previous one. And as you can see, the only difference here is that on line 9, on the 9th line, instead of using write binary, we are using append binary. Hence why it's AB. Now let's just run it and see how it works. And as you can see, it's going to ask us, please input the amount of new additional menu. Let's say I just want to add another menu, and the menu is going to be called beef satay, and the pricing is going to be 20,000 rupiah, like so. Now process exited, press any key to continue. It's gonna exit it, and now we're going to back it off to the read program and going to be compile and running it once more. And as you can see, the fried rice, the fried chicken, and the beef satay is still on the list. Instead of overwriting the previous one using append, you're going to be adding one. Now the next subpoint is going to be randomly accessing binary files. Now you're going to be learning a new command called fseek. Here is the basic form of fseek. As you can see, you have the file stream, which is a file pointer that points to a file. We have the offset. An offset is actually the value of the byte adjustment to the whence reference, and the whence is the file position indicator reference. Now there's actually 3 position for whence. You have onset location, which is going to be using seek set, and that's going to be on current location, which is going to be using the seek current, and on end location, which is seek end. Here are a couple of examples on how to use them. As you can see, in number 1, we have fseek, file pointer, 3, and seek set. What does that mean? That means that the file position indicator will be changed 3 byte, hence the 3 right here, after the beginning of the file. The beginning of the file because it is set as a seek set. the whence is 6 set. And on the second example right here, we have actually a negative number right here, which is a negative 3. What does that mean is that the file position indicator will be changed 3 bytes before the end of the file, hence because it is a seek end. But as you can see, the negative number change it into before instead of after. Now on the third example, we have fseek 3 and seek current. What does that mean is that the file position indicator will be changed 3 bytes after the current file position indicator. Now on the fourth and last example, fseek, and you can see there is actually a size of right here. Instead of a whole number like 3, this is going to be using a size of, and it's going to be using a size of some data. Now what does that mean is that the file position indicator will be changed based on the size of the data object before the current file position indicator. So if you don't know how much whole number you need to input, you can probably just use size of some data. And here is the code example for fseek. And in line 1, you have a header declaration, and the second line you have the int main. The third line is going to be a file declaration. The fourth is going to be an integer declaration called struct number. The fifth line is going to be a long int declaration, byte offset. What is 2 for? We'll get right to it. The 7th to the 10th lines is going to be a struct named list, and as you can see, we are still using the same name, same everything, same string, same double variable name, which is price, just to avoid confusion. And the 12th line is going to be where the file is being opened, and as you can see, the mode is read instead of write because we only want output instead of input. And on the 13th line, it's going to be asking us the desired number order of menu and the list. On the 14th line is going to get the number. On the 16th line we are going to be declaring the byte offset. The byte offset is going to be declared as struct number subtracted by 1 times size of list. Size of list is of course the struct. Struct number is going to be the number that we inputted previously. And on the 17th line, we have where the fseek is located. Now the fseek is going to be manipulating this line, and the offset is set by this byte offset variable, which is declared as this. Now that is the offset right here. So instead of inputting a whole number, we use these calculations for the offset. And now the whence is going to be 6 set, which is the position is going to be from the start of the file. And on the 19th line, we have again fread, because previously we are only seeking something, but now we actually wanted to read that something. Now there's actually a condition. If fread outputs a 0, they will print out the associated menu cannot be found on the list. What does that mean is that whenever you inputted a larger number than the list of menu, let's say the list, we have only 3 menus on this program, but let's say you inputted a 4 or a 5. Now the program will spew out or will print out this line right here. The associated menu cannot be found on the list because there's no such thing as a 4th menu because we only have 3 menus. Now else, or if fread doesn't output a 0, or let's say a 1 or something else, it will going to be outputting this, which is the menu and the price. And of course, 26th line, fclose to close your file. Let's just run this. And let's say that we want a beef satay, which is going to be a number 3. And if we put number 3 right here and hit enter, as you can see, the beef satay will be printed out with its pricing, which is 20k or 20,000 rupiah. And lastly, on randomly accessing a binary file is the rewind function. This is the basic form of the rewind function. It literally just a rewind and your file stream right here, or your file pointer. Now what does rewind do? It basically just sets the file positions to the beginning of the file for the stream pointed to by stream. Now this rewind function does not give any output whatsoever.
Alright, we will continue about erasing data in binary files. In erasing data, we will use two new functions. In here, we have remove function and rename function. In the remove function, the file name in here we can access anymore because the file name in here we will to delete it. And then in the rename function, for the rename function we will change the old name to the new name. And for the procedure erasing data, first one, we open the main file in read mode or in RB mode. And two, we create a temporary file and open it in write mode or WB mode. And third, we copy all the data from the main file into the temporary file, except the data which will be removed, because the data that will be removed will keep main in the main file. For the data that we don't want to remove, just copy to the temporary file. And fourth, we close the main file and the temporary file. And fifth, we remove the main file because in the main file in here that contain the data that we want to remove. And six, we rename the temporary file, the name based on the main file name. For the 7, we remove the temporary file because the temporary file is changed its name to the main file name. For the code in here, I have already two data. First one is bakso for 12,000, somai for 10,000, and tahu for 5,000. In this erasing data, we use library include string.h because in here we will search the data that we want to remove. First one, we declare the main file and the temporary file. For the main file, we use name f structure, and the temporary file we use the f structure too. Then for the declaration for search name, in here in the 7.7 and the 0.8, we declare struct for the menu and for the harga. Then for this 13 point, we open the file main file. In here, we choose name for the main file is daftar.dat with the mode EB or reading mode. And for the temporary file, we use name daftarharga2.dat in white mode or WB mode. And in 15.15, we will input the data that we want to be erased. So in this while here we will copy the data that we want to from the main file to the temporary file. In the temporary file will contain the data that we don't want to erase. And then we close the file because for the main file and the temporary file. And then we remove the main file in here. We remove daftarharga.dat, and for the temporary file we will rename it from daftarharga2.dat to daftarharga.dat. Daftarharga.dat is the name for the main file. Okay, so we go to compile and run it. For the menu that we want to erase, I've already three from before is tahu, somai, and bakso. For example, we want to erase tahu. Okay, and here tahu has been erased, so we check it again. Alright, in here just two data because tahu in here has been erased from the file. Okay, for the next is close file. In the close file is f basic form is f plus file stream. For the stream in there is file pointer that point to file. Then f plus is eliminates the data flow of files designated by the stream and close the file in question. So the f plus e in here just to close the data and stop the stream to flow. And for the f close function will return 0 if the data flow was successfully closed or IOF in an error was detected. Each fopen must be ended with f-close. This is very important because if, for example, if we open the book, we will close the book, alright? Then for the addition, here, we will be emptying the buffer in the data flow. In this basic form of emptying the buffer is f plus file stream. Buffer data, buffer for the writing process that has not been written in the flow of the data will be written first. The f plus function will set an error indicator for the data flow and return the IOF value if a writing error occurs. Otherwise, it will return 0 value. And for the writing and placing position indicator, in here we have f post t is a data type that can store information needed to uniquely determine its position in a file. In f post t is in here and here too. And fgetPost will store the file position indicator in the object pointed to by the post, and for the fsetPost will change the file position indicator based on the value of the object pointed to by the post. And both of these functions, but for fgetPost and fsetPost, will return 0 integer if the operation is successful and otherwise defined based on the implementation of a platform if it fails. So this is the end of the video. Thank you for watching. I hope you will learn something from this and see you next time.